All right, graphing polynomials part 2. I just wanted to give you 2 more examples of some problems that are a little bit more difficult. In particular, you may notice this a little more difficult, but we should know how to factor this. And so this is x plus 3 and x minus 3. And so listing our zeros shouldn't be any more difficult. So our zeros here are -2, 0, and -3, 0, and 3, 0. And so over here on our axis, we want to go to -2, 0. We want a 0 at -3 and at +3. All right, and then we want to find our y-intercept. And so for our y-intercept, plug a 0 in for our x's. And so we get -0 plus 2 squared times 0 squared minus 9, which gives us a negative times 2 squared times -9. So negative times 4 times -9, which gives us a positive 36. So our y-intercept is 0, 36. So if we go up here to 36, or approximately, like I said, these are sketches. We want to identify the end behavior, and so usually the exponents are outside of the parentheses, like this first one is, but from time to time you'll have the exponent on the inside. And so this is still a 4th degree polynomial. And so x plus 2 could also be x plus 2 times x plus 2. And so that's why it's a 4th degree. So it's going to have an end behavior like a parabola. But if you notice, the minus sign out in the very front is going to make it like a negative parabola. So we want this thing opening down and finishing down at -3, our graph is going to cross. At -2, it's going to bounce, so we got to come back down. We bounce at -2. We're going to come across at 36, and at +3, it should also cross. And so this would be the sketch of our graph. All right, one more example. If you notice, there's some similar pieces to our last problem. You may want to rewrite it. You don't have to. But here, if we rewrite it really quickly, you can see that we have x squared minus 4, but that is also squared. So that is like us having x squared minus 4 times x squared minus 4 times x minus 3. And so if you wanted to rewrite it even further than this, then you would have 2x minus 1 times x plus 2 times x minus 2, and that comes from the x squared minus 4. That's the difference of perfect squares. And so you'd have another x plus 2, another x minus 2, and then your x minus 3. And so I know it looks like quite a bit. You may or may not have to rewrite that. I think it is important to notice that we have 2 x plus 2 terms, and we have 2 x minus 2 terms. So at those zeros, we have a multiplicity of 2, and so it will bounce at 2 and -2. So if we write out our zeros, we see we have zeros at 1/2. So 1/2, 0. So over here, if we have 1, there should be our 1/2. And then we have a 0 at -2, 0. We have a 0 at 2. Because these repeat here and here, if you want to, you can write x2 and x2 for times 2. They happen twice. And then we have a 0 at 3. And so we got another point at 3, 0. Our y-intercept, we're going to plug a 0 in for our x's. So 2 times 0 minus 1 times 0 squared minus 4 squared, and 0 minus 3. And so again, this is our y-intercept, how we find it, plug in 0 in for x. And so 2 times 0 is 0, so we get a negative 1. And then 0 squared is 0, so we get negative 4 squared. And we get a negative 3. And so we get negative 1 times a positive 16 times a negative 3, which gives us a positive 48. So at 0, 48, we have a y-intercept. So up here at 48. All right, so what is the degree of this polynomial? Well, here we have a degree 1, here we have a degree 1, and here we have a degree 2. So you may say degree 4, but you have to remember that x squared minus 4 is repeated. And so maybe if you look here, degree 1, degree 2, degree 2, and degree 1. And so that is a total of a degree 6 polynomial. All right, so that means it has an end behavior like a parabola. There is no leading terms in any of these parentheses and no leading term up front that is negative. So we're to assume that it has a positive parabolic end behavior. So it starts up and finishes up. And we do want to pay attention again. If you look over here at the zeros, how I have it listed, we see at negative 2 and 2 it's supposed to bounce. And so if we come down, we know at negative 2 it bounces. It has to cross at our x-intercept. At 1/2, it crosses. And then it comes back up to 2. It bounces and comes back up through 3. And that is the sketch of our graph. Okay, guys, I hope this video has also helped.